From the early days of aviation, its progress has been advanced by Smith's Instruments and Systems. It was Smiths who introduced the first British all-electric autopilot, which led in turn to the development of the SEP-2. This versatile autopilot has acquitted itself so well that it has gone into service all over the world and been installed in 12 different types of aircraft, including the Britannia, the Comet, the Vanguard, the Viscount, and the Vulcan. The SEP-2 is produced at Smith's Cheltenham factory, and it is here that continuous development has now achieved another major advance. This is the Series 6 Flight Control System. Several years' work have been devoted to developing the Series 6 system, which is designed for aircraft of all types, from the small executive aircraft to the sophisticated airliner. It combines exceptional performance and reliability, easy maintenance and low cost, with a remarkable reduction in size and weight. This has been achieved by advanced circuit and component design, including the use of directly coupled silicon transistors, solid-state switching, and improved assembly techniques. While reliability is ensured by operating components at levels well below their ratings and by exhaustive testing. Maintenance is made extremely easy by the provision of built-in test facilities and the use of plug-in modules. The compactness of the Series 6 can best be shown by a direct comparison. This, for example, is a servo amplifier from the SEP-2 system, and this is the equivalent unit from the Series 6. The complete equipment is made up of 3 individual systems: the SEP-6 autopilot, the SFS-6 flight system, and the SCS-6 compass system. The autopilot system consists of 3 computers, 3 servo motors, rate, height, and airspeed sensors, trim indicator and servo motor, autopilot controller, and mode selector. The mode selector has an interlock facility, which makes it in effect a mode indicator as well. The Series 6 flight system includes 2 entirely new instruments, the H6 Director Horizon and the S6 Flight Compass. They display heading, attitude, and flight director information, simply and without ambiguity, to both the pilot and the co-pilot. The other units are the flight director computer, comparator, vertical reference units, height sensor, yaw rate sensor, and the flight director controller. The family is completed by the SCS-6 compass system. It includes a new miniature directional gyro, together with an amplifier, detector, mode switch, and annunciator unit. A complete Series 6 installation fulfills all requirements for an intercontinental airliner. Smaller aircraft, of course, need only the basic equipment, and the systems can be built up stage by stage wherever this is desirable. For example, the first step in a progressive autopilot installation is provided by a yaw damper. The computer, together with the yaw rate sensor and servo motor, gives full-time independent yaw damping. The second stage provides basic autopilot facilities by adding pitch and roll stabilization and maneuver control. The third stage brings in height and airspeed locks, with Mach lock if required, radio coupling, automatic pitch trim, and push-button controls. The addition of the engage and trim indicator completes the autopilot system. The SEP-6 autopilot, the SFS-6 flight system, and the SCS-6 compass system are each self-contained. They can be used in isolation or in conjunction with each other. All are designed to ARINC standards to ensure integration with other manufacturers' systems if required. The full range of Series 6 equipment is installed in Smith's Hawker Siddeley 748 test aircraft. And as you see, the cockpit layout and instrument displays are clean and uncomplicated. Let's take a closer look at the flight instruments. The director horizon combines the functions of a remote artificial horizon and a compensatory type flight director. Horizon information and aircraft attitude are clearly displayed on a roller blind, while roll and pitch scale markings are distinct and unambiguous. Two indices display pitch and azimuth command information as selected on the flight director controller, which provides similar command facilities to those of the autopilot. Since these are completely independent, the flight director can be used to monitor autopilot performance. Failure of the flight director system is shown by a flag and by the movement of the indices to an unrealistic position. Similarly, failure of the attitude system is signaled by another flag, while loss of power causes the display to react immediately. The flight compass presents navigational situation information, aircraft heading being displayed by a moving compass card. Headings to fly, which are indicated by a movable index, are selected by using the left-hand knob, or they can be remotely selected via a servo repeater within the instrument. An electrical signal is available to provide a steering command for the autopilot and the azimuth flight director. The right-hand knob is used to position the inner display in accordance with radio navigational information. The selected course is also displayed on the right-hand digital readout. On VOR, the instrument functions as the omni-bearing selector. Nautical miles from DME are shown on the left-hand digital readout. As with heading selection, remote operation of course selection is provided for. System or power failure is shown by a warning flag, and operation of the azimuth gyro in either a free or slaved mode is indicated by a DG flag. Radio beam displacement and ILS glide slope information is shown by the bars in the center display. Radio failure flags are also provided, glide slope on the left and beam on the right. And now let's take a short flight and see the Series 6 system in action. Before takeoff, the pilot engages the yaw damper by using the switch on the autopilot controller and normally keeps it engaged until after touchdown. He flies the aircraft manually while the after takeoff checks are completed. Then he uses the autopilot engagement switch to bring in automatic roll and pitch control. The engagement of these basic modes is indicated on the mode selector by the lights in the roll and pitch buttons, which are depressed. The engage and trim indicator also signals that the autopilot and yaw damper are engaged. The aircraft is now proceeding on attitude lock, which the pilot can trim by using the pitch trim wheel and the bank control knob on the autopilot controller. When the bank control knob is in its center detent, the roll channel maintains the aircraft on constant heading. By turning the knob in either direction, any desired bank angle, up to a maximum of 30 degrees, can be obtained. On returning the knob to its center detent, the aircraft rolls gently out of the turn. The pitch trim wheel is equally gradual in its effect, and the pilot now uses this control to trim the aircraft to climb at the required speed. Then he presses the IAS button on the mode selector to engage the IAS lock and hold the aircraft at that speed. To select the heading he requires, he uses the steering index on the flight compass, then presses the heading button on the mode selector, and the autopilot automatically turns the aircraft, which is still climbing, onto the selected heading. The height required has now been reached. and to level out, the pilot presses the height button on the mode selector and height lock on the flight director controller. The aircraft, now being at the required height, proceeds locked to height and heading. A feature of the Series 6 system is its any-angle VOR and ILS capture facility, and the pilot now takes advantage of this in coupling to VOR. Having tuned his radio to the correct frequency, he selects the required radial with the course pointer on the flight compass, uses the steering index to select the heading at which he wishes to intercept the radial, and presses the beam button on the mode selector. Both heading and beam buttons remain depressed, and the autopilot is now primed for the beam mode. The aircraft continues on the interception heading selected on the steering index. When the radio signal falls to an appropriate level, the heading button automatically trips out, and the autopilot goes into the beam mode, turning the aircraft to capture the VOR radial. During the capture, the flight compass shows the relative position of the required radial and the reducing deflection of the beam bar until the aircraft subsides onto the radial, automatically applying a drift correction, while the compass display continues to give a pictorial presentation. While the aircraft has been approaching its destination, the pilot has descended on airspeed lock, adjusting his rate of descent by power and relocked to lower height for the intermediate maneuver. He intercepted the ILS localizer using the same procedure as we have seen for the VOR capture. The aircraft is now established on height lock and completing the turn onto the localizer. At this stage, the pilot presses the glide button and the aircraft is now primed for the glide mode. It continues on the localizer and on height lock until reaching the center of the glide slope, when the height button trips out. The autopilot goes into the glide mode, and the aircraft starts to descend on the glide slope while continuing to hold the localizer center line. Any deviation from the localizer or glide slope will be shown on the flight compass by the beam and glide slope deviation bars.
Gatwick, Juliet Tango, Altamarca finals.
Clear to land, Juliet Tango. Surface wind 220, gusting 25.
Juliet Tango.
The high standard of tracking between the autopilot and the flight director also ensures a high standard of flight path monitoring. The Series 6 system has been designed from the outset to operate safely in bad weather conditions, well below present-day break-off heights. It can be easily extended for low-weather minima operation by the incorporation of the autopilot monitor, auto throttle system, head-up flare director, and overshoot director that Smiths have developed for this purpose. As the aircraft approaches the runway threshold, you can see the accuracy of the approach coupling. To sum up, the Series 6 is compact, low weight, low volume. Compatible, conforms to airing throughout. Competitive, consistently reliable performance at low cost.